Hey everyone, welcome back to Ask Becca About Space. This week I'm pretty excited because I get to answer some new questions, but also because I've spent most of this week pretty much back at university. The university opened officially, I guess, on Monday. So everybody who would like to be here is able to be here. If we choose. And for me, it's a lot more space in my office, and I have all these, as you saw last week, all of these kind of giant screens and all this stuff going on. Oh my gosh, my friend's walking by. I haven't seen her in like 6 months. Oh, 6, 3, 4, I don't know. You guys know that time is irrelevant during COVID. Yeah, so a couple of different things today. I am just in one of our conference rooms at the Institute. Sun is behind me as per usual, but it is a different view of the sun. I can actually show you kind of what this picture is, I guess. So this picture kind of shows us a bunch of different layers of the sun that we can see, and this lighting is not the stuff, I get it, but this is a low budget operation. So the kind of photosphere surface of the sun, this is what this is where we see things like sunspots here. And this just says HMI. That is the telescope that we can use to observe that layer of the sun. It's called HMI. These 3 pictures are layers of the atmosphere as you increase in distance away from the sun's core. So increasing the radius you are away from the sun. The chromosphere here is the lower layer of the atmosphere that's right above the photosphere. And we can observe that in what's called AIA 304. So 304 refers to the wavelength of light that's being sampled, and AIA refers to the instrument that's sampling it. These 2 up here, these are pictures of the corona, what we call the corona. And I've talked before that the corona is another word for the sun's atmosphere, because corona just translates to the word crown. So yeah, that's the sun's atmosphere, and this one is in AIA 171, so wavelength reference 171, instrument AIA, and this one's AIA 94 plus 335 plus 193, so it's a composite image of 3 different wavelengths observed with AIA, and all 3 of those instruments are on board the Solar Dynamics Observatory, which we've talked about before as well, okay? So that's what's behind me. This is where I work. I did my brows. It's not mandatory, but now that I'm out of the house, I felt like, well, might as well do these brows. Anyway, so today, my friend Joy, the one and only Joy Eggert Reed, sent me some questions from her nephew Jackson. And so I'm going to answer a couple of those today, just because y'all know I like to talk and ramble a little bit. So to make this video a reasonable length, I'll do 2 today and 2 next week, okay? So Jackson asks, number 1, could there be life in a different solar system? Well, sure, there could. Okay, so here's the thing about the search for life. The search for life is something that's been going on for the past several decades. But the thing is, when we're looking for life outside of our planet, we have to understand what it is that we're looking for, right? Are we looking for life that looks like us? Are we looking for intelligent life, like plant and animal life? Or are we just kind of wanting to start with the basics of life, amino acids, DNA, microorganisms, bacteria, things like that? So as of today, we have not been able to find any definitive signs of life anywhere. It is probable that life on this planet, as the planet was forming, was populated by what it was that was forming this planet, right? Things like asteroids may have been carriers of the building blocks of DNA and things like that. But as far as life that's evolved in terms of like, even to the bacteria stage, right? Much less plants and animals and humans. We haven't found anything like that. What we have found is a set of criteria to look for life that looks like the kind of life that we understand, because the kind of life that we understand is carbon-based life. That's what we call organic matter, okay? So in the search for organic matter, because that's what we understand the most, because that's what we are, we found a couple of different possible sites of potential life, either now or throughout history, in our own solar system besides on the Earth, okay? And those places are places like Mars, which used to have water, places like Saturn's moon Enceladus and Jupiter's moon Europa. I almost forgot its name for a second. So Enceladus and Europa, these two moons are thought/known or are observed to have oceans, water oceans underneath a thick crust of ice. So what's going on with that is like, well, the criteria for life, well, we need water and we need an energy source, at least. You need at least those two things. And with these two moons, we do have liquid water, the oceans underneath the icy surface that are erupting occasionally through the icy surface in ice volcanoes. And because they're erupting with ice volcanoes, that means that there's an energy source there, some sort of source of heat or energy that could sustain life. And we have organisms, even on Earth, that are called extremophiles. And what extremophiles are is basically, if you break down the word extremophile, it kind of just means lover of extremes, or attached to extremes, or has a preference for extremes, right? So these extremophiles can live in extremely crazy environments, extreme heat, extreme pressure, extreme darkness, things like that. And we've found, especially in the oceans, organisms that can survive things like that. So if we find environments that sort of mirror those extreme environments in our own solar system, then we can extrapolate that to hypothesizing that maybe there's also similar types of extremophiles that live there. Okay, but you asked, is there probably life outside of our solar system? Carl Sagan, who was a very famous astronomer, once said something like, paraphrasing, if there isn't life outside of the Earth, then it's a tremendous waste of space, right? If there's not life in the universe besides here, then what a tremendous waste of space. And I'm kind of inclined to agree with him, right? Because if the conditions for life were so perfect on Earth that we were able to adapt and grow and evolve out of those conditions, who's to say that those conditions don't exist elsewhere, right? So currently, what's going on is there's a mission called Kepler, and Kepler is a spacecraft that is basically staring at one kind of square of the sky all the time. And that square of the sky has a pretty high density of stars. And basically what it's looking for is it's looking for other planets, so other solar systems, and it's found a ton. And so once you've found the planet, you can study the planet and try to understand if it has any air in its atmosphere. And by using the way light travels through that air, we can try and figure out what that atmosphere is made out of. So that's what we're working on now. We're trying to understand how to best do that. Because one of the reasons that we have life here on Earth is because our atmosphere is made of mostly nitrogen and oxygen, and that suits this type of life well. So if we're looking for life at another place, then a good place to start, if it's so far away that we can't really detect water yet, a good place to start is to find out what's in their atmosphere. So to answer your question, yes, there definitely could be life in other solar systems, but no, we have not found it yet. But I believe that we're on the brink of being able to detect things like that. And again, it depends on what type of life you're looking for. If you're looking for tiny little microbes up to something that's like a human, there's a big spectrum and a big difference between those things. But I mean, statistically, these things certainly could exist in other solar systems. Okay, moving on. Number 2, sort of related. Can a planet from one solar system move to another solar system? That is a great question. So theoretically, yes, but most of the time, no. And here's why. So solar systems are categorized generally by some center of mass body that involves a star or two or three, depending, mostly a star or two. And in that center of mass, that basically means this is the center of most of the stuff that is involved in the entire system. That's true in our solar system. The sun contains the majority of the stuff, the majority of the mass, and it is in the center of our solar system. And everything else is caught in a gravitational orbit around that body. Okay, so that's kind of how solar systems are, simply put. Now, what we have are things called wandering planets, okay? And a wandering planet is not going to be found very close to its host star. It is, in fact, going to be found so far away from its host star that it's kind of wishy-washy whether or not it's actually caught in the gravitational field of that star, right? Is the orbit still an ellipse that's going around that star, or is this just kind of caught in between multiple gravitational fields? Now, if the solar systems are sufficiently close enough, it's possible that a wandering planet on the outside of one solar system could cross into the threshold of the outside of another solar system, but that's not something that I know has been observed. Okay, so that's, to my knowledge, we haven't seen something like that happen. Theoretically, I suppose it could. And one of the reasons that we have wandering planets is because the gravitational systems are so intense. Oftentimes, things like this happen because perhaps there's a black hole or a supermassive star and the planet was kicked out of its regular orbit by some external force, right? Because the laws of orbital motion are pretty concrete and pretty stable unless you introduce some other thing into the system. Something like, I think this actually alludes to your third question. Yeah, it does. So stay tuned for next week. But something like a star exploding in the solar system, or being too close to a black hole, or having what we call a type 1 supernova, which needs a white dwarf to kick it off, like a smaller star to kick off the explosion. These are also called pair unstable supernovae, but we can talk about that later. Yeah, so theoretically it's possible that things go wrong, but not in a stable system. I guess the bottom line is no, not if the system is stable, but if something else happens in the system, because the universe is wild and sometimes stuff happens, right? If something else has caused a planet to wander outside of its normal orbital path, and the two systems are sufficiently close, such that the gravitational fields overlap, perhaps, or the gravitational fields are close enough such that one takes over eventually, or that there's another external force somehow, then I suppose it's theoretically possible. But again, it's not something that happens a lot, because most of the time nature is just trying to find balance. And balance means stable orbits, stable systems. But you're right. I mean, that's not always the case. Even if nature tries to naturally tend towards stability, that doesn't mean that it's always stable all the time, right? That's true about everything. So, yeah, so to answer your question, it's possible, but it's not very likely, okay? So, Jackson, thank you for those questions. I will address your other two questions sometime next week. And if you have any more questions, feel free to let me know. I'm just in the office. I've got some busy things coming up with my work life and my personal life, so all good things. And but I'll be around. I'll be available to talk to you guys whenever. All right. So continue to take it easy. I hope you're staying well, and I'll talk to you soon.